summation notation, which we've seen before in college algebra. I'll just give a quick little reminder of it. So if I have this symbol, start with some variable. In this section they use only I. I know when we did college algebra we had I, we had n, sometimes put an x there. This is your starting point. This would be your ending point. Okay, and then typically you have some type of function in here. So let's just say it's just I. Okay, well what this means is this is a counter from 1 to 5, and we're just going to count up 1, then to 2, then to 3, then to 4, then to 5, that's our last number. And as we do that, we're putting these numbers into that function. In this case it's just I. And then when we're done with all that, we're going to add them up. So my first number would be 1. Second one, count up to 2, so 2 goes in to there, then 3, then 4, then 5. So this one's actually pretty easy to add. It's just 6, 6, and then another 3. So what do we get? 15? Okay. So hopefully that was a review for us. There's also a button on the calculator which will come in handy for a lot of the problems we're doing. Okay. Tricky part is when this thing up on top turns to an N. That's when it gets a little bit tricky. It's tough to put in your calculator then. So what you need in order to do those is maybe some formulas. So if you look at page 291, they give us 4 different formulas. Okay, the first one is when we go from I equals 1 up to n, and then we just have a constant here. Okay, just a number. So let's see what that would look like. So let's say that number is 2. Let's say I equals 1, and we're going to 5 again, and then just the number 2 out here. Well, what's my first term in this sequence? Because that's what these are. These are sequences. So when I is 1, I put I into this, but there's no I to put in here, so what's my first term? 2. Just 2. Plus, put I turns to 2. Put a 2 into I here. There is no I, so it's just 2. So how many 2's am I going to have? 5. I'm going to have 5 of them. Oops, they don't turn 3. Okay, so how many total 2's? Well, I should have that many 2's. So can you see pretty quickly how this is just going to equal C times n? However many 2's we have, that would be the n, so we just multiply it. So this would equal 2 times 5, or 10. Make sense? Gets a little bit trickier from there. Maybe we can't make it nice and easy. This one's really easy to see. The next one's not as easy to see. There's probably some proofs in the book somewhere that show it. But now let's say it's I. Okay, this formula is, and I probably won't write down all the formulas, maybe just this one, because there are the 4 there. And maybe that's what that QRF code is. That would be a proof of these. That's my guess. But again, we don't necessarily need the proof. If you want the proof, maybe to help understand. Okay, so when you have I equals 1 to the n of just I, you get this. So then you're going to run across some problems when you start doing the homework of, say, 7I. What would that be? That would just be, you could bring the 7 out front. It's just 7 times all of this. Make sense? So that's how that works. Like if there's a...
Shouldn't we not put I out front of the equation to start with?
That one? What do you mean, the 7?
No, you just said that.
So this can be rewritten like that. 7 times all of that. So if you have this, it's just 7 times the I. You can break it up like that. So why do we need to do this? So here's where we're going with this. It turns out all geometric shapes, every single one of them can be broken up into other geometric shapes, for instance, triangles, okay? Or and what we're going to be doing is rectangles. But they go over that on page 292 real thoroughly. I'm not going to read it all to you, but you can break polygons up into triangles. You can break circles into triangles. Okay, so So it talks about all of that. But what we're interested in is under a curve, we can break a curve into rectangles. Okay, make it a little more exaggerated here. Okay, so I can break this curve into rectangles. Let's just start with a known number of rectangles. Let's have that be what, 1, 2, 3, 4. Let's say there's 5 rectangles I can break this up into. So here's 1. Okay, here's 2. Here's 3. Here's 4. Here's 5. Okay, that's one way of breaking this up into rectangles. Here's another way. Okay, again, same. I'm going to use 5 again. So let's say these are the exact same objects. Okay, this time I'll use blue. 1, 2, 3, 4, 5. So this time, I'm going to break them up like this. What's the difference?
One is overestimating, one is underestimating.
Yeah, very good. So, yeah, one is an overestimate, and one is an underestimate. So I guess I should start with the question of the problem. What's the area under this curve? What's the total area from here to here? Basically, my area, what I'm talking about is the area from y equals 0 to x equals 0 to this function. I'm just going to call it f of x because I don't actually know what it is. So here's y equals 0, here's x equals 0, and then here's that function. What's the area inside those restrictions? Okay, those are the type of problems we'll be doing all the way up through 4.4. Okay, and we're going to see a couple different methods on how to do them. Kind of like how we started with derivatives, how we kind of went the long way to hopefully understand it a little better. And then there's kind of a shortcut, but hopefully, like we said, hopefully we understand the long way a little bit, and then when we get the shortcut, it's a little bit easier. But yes, there's this, when I box, this is called a left side box. Left side estimate, because I'm starting with the box on the left side. See that? So what do you think we're going to call this side? Right side estimate. In this case, the left side estimate is an overestimate. The right side is an underestimate. Okay? Now, what would happen if I made my boxes smaller in both of these?
They both be under.
No, this, if I made the box smaller, I'd still be an overestimate, but now I'd have more boxes, right? I should be closer, right? So this is called kind of the pinching method, right? How eventually they both should meet up at what? The actual what? The actual area, right? We have our underestimate, we have our overestimate. The smaller we make these boxes, the closer we get to our actual answer. In fact, we're going to show that we really don't need both of these to find the answer. We just need to take a limit of one of them, and that will give us the answer, but it kind of walks through how to do it with both of these. Okay? Another thing to consider is, so these are called inscribed. I should probably talk about that. These are called the inscribed rectangles. These would be the circumscribed. Is that what they're called? Circumscribed rectangles. Okay. So, in this case, the left side was an overestimate. Can you guys think of another function where the left side would be an underestimate and the right side would be an overestimate? Okay, good. So how is this, what is happening to this function? It's what? As I go from here to here, it's decreasing, right? Okay, I hope you can imagine another function that maybe would look like this. Okay, and then let's say it's cut off this time. Let's call this the function. Again, our limits are x equals 0, y equals 0. Let's have x equal 5. And then this function. Okay, so those are our limits on this object. the x equals 0, that's this line here. Y equals 0, that's this line here. The function is this line, and then there's x equals 5. I want to know the area within these restrictions. Okay, well if I start making the triangle or the rectangles, okay, so here would be, this is the left side. And again, it's they'll tell you how many rectangles to make. Let's say I was supposed to make 5 again. Okay, can you see how now over here, the left side estimate was an overestimate? What do you notice here? No, it's an underestimate. Okay. All right. I think we got an idea of that. So let's hop into example 3. It says approximate the area of a plane region. Use the 5 rectangles to find 2 approximations of the area of the region lying between the graph of f of x is negative x squared plus 5, x equals 0, or excuse me, yeah, x equals 0 and x equals 2. I think I might have had these wrong. This would be x equals 0, right? This is x equals 5. I think I was calling this x equals 0, but this is y equals 0, right? Okay, if I misspoke there, sorry about that. This is x equals 0, this is y equals 0. All right, anyways, so here we go. X equals 0, x equals, I think they have 2. And the y-axis, so and y equals 0, so that'd be the bottom. So this object, if we graphed it out, I'll just use their graph, looks something like this, okay, where here's x equals 0, here's y equals 0, here's the function. Okay, and then they actually want us to cut off at 2. So let's say this is 1 here, 2 is about here. So they don't want us to add up the area over here. That's not quite a straight line. You guys understand what I'm doing, right? All right, so they want us to break these up into 5 boxes. Okay, if we do that, and we're going to do the left, right endpoint. They want us to do the right endpoints of the 5 intervals first. Okay, we can do that. So the first one they want us to do is the right intervals. So that means I'm going here, 1, I'm not going to draw this perfectly. There's supposed to be 5 of these. Yeah, let's say I messed up here. Let's say there's 1 there. Okay? All right, well, how do we find the area of those 5 rectangles? What is the area of a rectangle? Base, we call it base times height, right? The base times the height, okay? So how do we find those? One thing to help you is let's just figure out what these intervals are, okay? What is this point here? 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 Because if we can figure that out, I think we can figure out what the height of each of these rectangles is. Okay, so we have a distance of 2, and we're going to break that 2 up into 5 groups. Okay, so how long would each box be? Yeah, does that make sense? We're breaking a distance of 2 up 5 times. So each width of these boxes is going to be 2/5. Does that make sense? Breaking up 2 5 times. And I'll give you a formula on how to find that as we get to later problems. It doesn't really talk about that here. Okay? All right, so this box, let's say this is the first one. What's my x value starting point? 0, good. What's my x value ending point? 2/5. Okay, that's the first rectangle. Does everyone understand that? What's the height of this rectangle? Or so the width of this rectangle is 2/5. We'll figure out the height here in a second. But that's the first, box. Okay? Next box. is what? They're touching each other.
2/5.
Yeah, 2/5 and what? 4/5, right? Each of these has a width of 2/5. What's my next box?
4/5
4/5 to
to 6/5.
6/5. Let's just leave it as an improper fraction. Okay, and then
6/5.
6/5
8/5.
to 8/5. And then 8/5 to 10/5, which is 2. So can everyone see that these are the 5 rectangles? Now, there's going to be a difference in the height of each of these rectangles based on if, this is pretty close to that, isn't it? Based on if we're starting from the left side, right? As opposed to if we're starting from the right side. So if this is our same object, can you see how this is 0, this is 2/5, right? But which of these numbers would we put into the function to get our height?
The highest one.
We put in this case, we put in 0, right? Do we see that? What would we put in for this rectangle to get the height?
2/5.
2/5. What would we put in for this rectangle? 4/5. This one.
So it's not.
This one. Good. What's that, sorry?
So it's not 2, like on the bottom, it's not 2/5 repeated.
Well, we'll get to that. We'll get to that. Okay? How about over here? So if again I'm 0 to 2/5, which number are we actually, which 0 or 2/5 are we putting in to get this first one? We're not putting in the 0 because that would get us up here. We're putting in the 2/5 into the function. Isn't that where the function is at? Where this x value and this y value meet? That would be the height of that rectangle. Okay? You guys see the difference? All right. Now, where does this summation notation come into play? That is supposed to make this problem easier for you. So, Celine, that's what you were already starting to bring up. Okay? If I put this into summation notation, first, I want to come up with a function. Okay? So a function is going to give me the area of this rectangle, which is base times height. And I'm going to switch it around because they have the base second. Height times base. What is for the one that starts from the left side? Okay, I'm just going to draw it out real quick. For this one here, what's the base of each, what's the width of each of these rectangles? 2/5. Does everyone see that? Okay. What's the height? Well, the height is going to be a function. Okay? How, and this is what we did. This is what we did in college algebra. The height is going to be a function with these numbers. So this is the left side, 0, 2/5, 4/5, 6/5, 8/5. How can I come up with an equation that gives me those 5 numbers? Do you remember doing this in college algebra? We came up with a series. Okay? First we figured how much these were changing by. Okay? Let's make an easier one. Maybe that'll help spark something. If I had the series 3, 5, 7, 9, let's say that went for infinity. Do you remember doing this? A of n equals something n plus d. Do you remember doing that? Come up with a series where I could put the n, so I could put a 1 in for n, and I'd get 3. I could put a 2 in for n, and I'd get 5. Remember doing that? Okay? So, the formula for that was a of n, a1 times n plus d. Okay. Here's the part you need to remember. What are these going up by? 2. No, we're using our problem now. What are these going up by? 2's. That's what you're going to put in front of the n. Okay? This D is something you're gonna put back here, so that when I put a 1 in, I get a 3. So what would that be in our case?
A one.
What is it? Something. In this case, it's just 1. Let's see if this formula works. Okay, if I put a 1 in, do I get a 3?
Yeah.
2 times 1 is 2, plus 1, 3. And all of these will be linear. Okay, all these are going to be linear. This is a linear series. If I put a 2 in, do I get a 5? 2 times 2 is what?
Yes, 4,
Plus 1.
5.
Okay, if I put a 3 in, do you see where I'm getting here? Okay, now another thing we did is if I just wanted 4 of these, you could make a sum. I equals 1. I have 4 terms. The 4 would go there. And then you just put this formula in. 2i plus 1. If I wanted to add all these up. Okay? With me? Celine, what part are you missing? You gotta ask the question. This equation, 2n plus 1. So first you look here. What are these going up by? 3, then 5, then 7, then 9. What are they going up by?
Why is the A1 in front of it?
A1 equals 3.
No, in front of the N plus B.
AN. So this is the formula we had in the book. If you're a formula person, this might help you. This would be your first term and then plus some D. But for most, it's just easier to hop right into this. What's the N going up by?
2.
How do I get the first term to be 3?
You got 1.
Okay? Okay, and then we can change it to a sum notation. And you're going to see why a sum notation is going to make sense in our problems. Alright. So this is where we've been. This might be a bit rusty because it's been over a year since we looked at this, right? Okay, and again, it's not essential to know this to do these problems, but boy, it makes it easier. Makes it a lot easier. Okay, because really all we're doing is adding up rectangles, right? There's only 5 of them. You can find the area of 5 rectangles, right? But let's learn how to do it with the summation notation, see how that helps us. Okay, so what is the height of this first, what's the height of this first rectangle?
2.
What's the height of this first rectangle?
0.
Not 0, because our
5.
formula is x, is it negative x squared plus 5?
Yep.
Okay, what are you doing to get that 5? You're putting in a 0. Good. So the first triangle has a height of 0 and a width of a height of 5 and a width of 2/5. That's the first rectangle. Yes? Okay? What's the height? Let's do the second rectangle. What's the width? 2/5 still. What's the height? Well, at this point, I'm going to start abbreviating. It's the f of 2/5, right? Where this was f of 0. Do you see why I'm calling f of 0? You see how if you put a 0 in here, that's going to give you the height? If I put 2/5 into here, that's going to give you the height of that one. Okay? Plus, what's the next one? F of what?
4.
F of 4/5 times 2/5. Okay? And so on. I'm just going to put some dots here. Okay? Because at some point we're going to add, I don't need to write all of them down. Do you guys see what I'm getting at here? So what we need to do, if we're going to use summation notation, we need to figure out how to get 0 to change to 2/5 to change to 4/5. Okay? So what's a series that gives us that? 0, then 2/5, then 4/5. What are they changing by? First off,
2/5.
2/5. Okay? I want my first term to be 0. So here's how we do that. That's our formula for the left side. It's the width times I minus 1. That will always give you the left side of each rectangle. Okay? Does it work? If I want the left side of this one, this is my first rectangle. If I put a 1 in here, do you see how this is 1 minus 1, 0? Do you see how that gives me f of 0? Okay? Put a 1 in here. This is my, put a 2 in here. This is my second rectangle. What's 2 minus 1? 1 times 2/5. Does that give me f of 2/5 here? Okay, this is my third rectangle. I keep calling them triangles. This is my third rectangle. What's 3 minus 1? 2 times 2/5. Does that give me that 4/5? So that's how they get. So here's how we set up our summation. I always start with 1. The top number is how many rectangles you want. For this problem, they tell us 5. They say we're going to use 5. So you put a 5 here. Okay? And then it's function of, for the left side, it's always going to be your width, in our case 2/5, times I minus 1. And parentheses, and parentheses. Okay? This is the height in our area argument. This is the height, right? So if I want to find the width, well, I just put that in here. Okay? This will work every single time you're doing these problems. 1 to 5, number of rectangles, width, and width. That's all it is. Okay? But now our job is to estimate what this is, or to actually find out what this is. So instead of function of this, I'm going to actually substitute this back into our equation, right? Because that, in order to get the height of the function, in order to get this spot right here, I have to put this x value into the function. Okay, what was the function again?
Negative x squared plus 5.
Negative x squared plus 5. So this goes into the function. And I like to put it in parentheses here, so it's going to be 2/5 I minus 1 times 2/5. Okay, does everyone see what I did? Oh, hold on, I'm missing something. What am I missing?
Plus.
Oh, I'm missing 2 things. I'm missing the squared
And the plus 5.
and the plus 5. So this whole thing gets squared plus 5 times 2/5. Okay? So, believe it or not, at this point you can actually put it into your calculator. I suggest doing that at some point to save you some time, but the problem is, at some point, this is going to turn to an n. This number here will be an n. This number here will be an n. You won't be able to put it in your calculator then, okay, unless you just pick a really big number for n. So it is going to be helpful to learn some of these steps coming up here, right? So here are the steps. First, we got to kind of simplify all of this. Well, I hope by now we know what I minus 1 squared is. I can do that off to the side. I squared minus 2i plus 1, right? Yes? Okay, and then what I'm going to do is take that times the negative 2/5. So I get negative 2/5 I squared minus plus 4/5 I, right? minus 2/5 plus 5, all of this times 2/5. Boy, at this point they must have just grabbed the calculator and just put it in. So, I don't know, I guess they're skipping over this next part. They're just putting it at this point right into the calculator. So maybe we'll just do that too. And a couple later that we'll solve by hand. Let's see if we can put it into the calculator first. So this is the left side estimates. This should be an overestimate, right? Go ahead, grab your calculator. Let's try put it in summation notation. See if we get the right answer. I think all the work is right. So you're going to need 2 parentheses to start here, 1, and then another one with a negative sign in front of it. Yeah, good. This does give us the right answer. If you put this in correctly, either one of these, we should get 8.08. I use the X symbol, like you're doing y equals, and then in both cases. So yeah, so in your calculator, these are X's. So this was, if you put this in correctly, you should get 8.08. What did we expect here? Is this going to be an overestimate or an underestimate?
Over.
This should be an overestimate. Was everyone able to get 8.08? Do I need to show how to put this in the calculator? Yes? Anyone? Anyone? Because I'd like to get to the other side of this, the underestimate. Anyone not able to get it? No?
I got 3.1.
Okay, I'll just show you quick how to put it in. It's really tricky to put in summation notation. It just is. Got to be real careful. Sometimes if you see a different sized parenthesis, there's a good chance that something's messed up. So here's how to put it in. All right, so math. Whoops, wrong one. Math. X 1 5. Careful, this is the part where students make a mistake. I'm going to put a negative sign and then another parenthesis. Okay, 2/5. So that's this part here. I need another parenthesis. It's x minus 1 n parenthesis squared. Whoops, need one more parenthesis there. Should have another parenthesis. So it should be, so it's negative, it's this is in parenthesis all the way out to here. Okay? Are we good to there?
Yeah.
Then we add the 5, n parenthesis times 2/5, and then we should have an n parenthesis there. Hit enter. 8.08. Okay? Now, that's the overestimate. How do you do the underestimate? Everything's the same, except instead of x minus, or I minus 1, it's just I. And I can explain that if you want me to. Left side, I minus 1. Right side, just I. Everything else is the same. So you could go back in and just delete the negative, the minus, the 1, and you're going to get to your other estimate. What did we get?
6.48.
6.48 is the answer. Now, what do we know about the area of this object?
It has to be between.
It's got to be between those two. It has to be between those two. That's probably good enough. That'll get you up to 32. That'll get you halfway through the assignment today. So hopefully we can grind that out and get up to that point. Then tomorrow we'll see, I should probably stop this.